So today I'm going to be talking about Java EE builds with Gradle. Just out of curiosity, how many of you are using Gradle already? Oh wow. Okay. With Java EE? Or just... Whoa, okay. I did a trial run last week and most of the audience didn't even know what Gradle was. Okay. So, well, I guess most of you will be familiar with this already, but for those of you that aren't, Gradle is an open source build automation system. It's under the Apache 2.0 license. It builds upon Apache Ant and Maven. It was first released in 2007. Uses a groovy DSL, not XML, which is a big improvement. It's much easier to work with than XML. It also gives you a lot more freedom. It uses a directed acyclic graph to determine the build order underneath. Importantly, it supports multiple languages, so you can build your Java EE application and your iOS application and your Android application using Gradle. So it is not just for Java. In fact, parts of the JDK, I believe Java FX, or different parts of the, I believe that, yeah, I know Java FX at least is built using Gradle now for the build system, including the native pieces. It has a rich plugin architecture and has convention over configuration, but is easily customized or customized or adaptable. So if you've ever tried to customize a Maven build or graft a Maven build into an existing build system, Gradle is quite refreshing in terms of being configurable. One of the nice things with Gradle is that the build file can be versioned like dependencies. So in the build file you can insert, which I'll show, the wrapper lines which specify which version, and you can check into version control, the version, basically a bootstrap that will build your project, the wrapper. So unlike Ant, where there are actually differences between different versions of Ant. So I've run into trouble between I run on, which is the approved build machine at work, Ant 1.9, and then other people, there's a couple of other people that still have like Ant 1.6 kicking around on their laptop because they haven't upgraded it in a long time. And so there's actually differences between different versions of Ant, and the build will fail. So if they use something different than what I have, it will fail. So there's actually a problem where some code that worked on 1.6 wouldn't work on 1.9. It wasn't backwards compatible. So it has a background build daemon to reduce build time, supports incremental builds, has built-in profiling support, allowing you to find out where it spent the different, what were the, where did it spend the time during the build. Can build projects in parallel, and also some tasks, I put that as an asterisk because that's, I believe, an incubating feature still. It has built-in Ant Maven support, which means that you can use Ant tasks in Gradle, and you can pull in and use also Maven tasks with Gradle. It supports several central repositories, Maven Central, JCenter, Ivy. You can use it with the internal, like an internal Nexus repository, which everybody should be running, or Artifactory, one of those two internally to cache and control artifacts. So this is kind of the build system evolution with Gradle. So Ant came out in 2000. It was great. It was better than Make, right? Everybody was singing its praises back then. And then after you ended up with the 10,000 line build files, which nobody could read anymore using references, we moved on to Maven to try to handle all those dependencies as the Java ecosystem grew, and our apps required 10,000 different jars to download. And then finally in 2009, Gradle came on the scene, building upon, giving you the flexibility of Ant and the dependency management of Gradle. So it's the next step in the build system. Now in terms of, I picked out just a couple of the features in Gradle that do not appear in Maven. I don't know why it has cutting it off on the overhead projector, but the green ones mean that Gradle has it. So with Gradle we've got, of course, a fully configurable directed acyclical graph which you can control. Maven, you don't have anything anywhere close to that. I believe it's just 2 levels that you get control over. You've got the ability to do task exclusion. You can do a dry run of your build, so you can find out what it's actually going to do before you actually build it. You have advanced control over task ordering, so you can say this task should run after this other task or before this other task. You've got control over that. Custom distributions especially if you're dealing with like legacy projects where you're trying to convert them over, like 15-year-old code bases, which I work on. You can't say, well, I'm going to refactor the entire code base to fit Maven, right? That's not, everybody stop development until I get the build working with the new one and figure out the 10,000 line Ant file and all the little itty bitty rules that it's doing where it copies files all over the place. So with Gradle you can build custom distributions. It's just not, you're producing a war, you're producing an ear. Repository aware cache, so if you have dependencies, the same dependency in two different cache in two different repositories is able to handle that situation. Version conflict resolution, so I believe with Gradle it's the closest to your project, with Maven it's the closest to your project, whereas with Gradle you can actually control that and say, well, I want this specific version. Nice things with Gradle is you can have file-based dependencies with your project, which allows you to, if you're integrating it with an existing project, with an existing build where you can't port the entire thing over at once, you can have new pieces of the build pull in stuff from the old build as file dependencies. The old Ant file that you haven't gotten around to writing that nobody understands, you can pull the jar file from that part of the build and include it in the new piece that's building using Gradle. So that's an important use of that. The ability to do build comparisons, Gradle can compare two builds for you. You've got the ability to create custom dependency scopes. So you can have a custom dependency scope for like an ATP for the annotation processors, which is important for like dealing with Eclipse link. Replaces by rules. So if you have a dependency that uses the older version of, I think it's Google Guava, which was previously Google Collections, you can specify, well, I want Google Collections to Google Guava to override Google Collections, that it's been renamed. I don't want it to include two of the same dependency, right? Because one of the projects I depend upon depends upon Google Collections, but I know that is now Google Guava, so I don't want to have two different jar files because they rename the project. So it can handle that, which Maven can't handle that out of the box. One of the biggest, another reason for why Gradle, a couple of years ago, Google has decided to switch Android over to Gradle. So this is a major step forward given the size of the Android ecosystem. I think that this is having, besides all of the features that come with Gradle, this will have a major impact on the Java in terms of pushing Gradle in, given that Google is pushing Gradle for Android. So that's definitely having a major impact. So questions if you're new to Gradle, which last time group I gave to, I had to go over this, which was, do you need to learn Groovy in order to write Gradle? No, but it's a good idea. You can kind of make do initially, with Gradle files, digging around, cutting and pasting stuff. It's not that different from Java. It's when you start trying to get into some of the more esoteric or leveraging it more. For basic builds, you don't need you don't need to be an expert at Groovy in order to use it. Do you need to completely refactor your code base? No. Unlike Maven, you can specify with Gradle where dependencies come from. There was years ago where I was trying to convert us over to Maven at work, and I refactored the code base, and after like a whole day of trying to get it to compile, and I was like, okay, this is not going to work because I can't tell everybody, don't check in code while I refactor the code base for Maven. 10 plus years of custom code and packages. Do you need additional IDE plugins? Maybe, and sometimes they work. Do you need to change your build process? It depends, because switching over to Gradle, especially if you have a legacy project, it offers you the ability to change it and to improve upon it. Do you need to port your entire build system over? No. One of the nice things with Gradle is that you can invoke it from Ant. There are plugins for Maven that allow you to kick off, a sub Gradle job. So if you're working on a large legacy project, you can switch it over to Gradle piecewise, which is what I've been doing. Where you write a new module, you use it with Gradle, but you don't have to affect the rest of the build, right? Because the build system isn't something we ship. It's what's used to produce the final product. So you can slip it in new pieces. Can you embed custom Ant logic? Yes, you can reuse some of the existing Ant logic that you already have. Must all dependencies originate from a repository? No, you can pull stuff in which you can leverage for pulling in parts from an older portion of the build system. Can artifacts be published to a repository like Nexus or Artifactory? Yes. Can Jenkins initiate Gradle builds? Most definitely. So why Gradle for Java EE? Well, Java EE projects are large, complex, and contain many dependencies. So you know, you'll very often have many modules that make up a Java EE project, and doing a full build with like Maven can be time consuming. Ant lacks so with comparison to Ant lacks dependency management and is a nightmare to debug. And with Maven, it really isn't flexible enough. Although there are plugins, it seems, for everything. It's trying to figure out, okay, I need a plugin to do this, and then anytime you need to go beyond that, you have to write a plugin yourself, which is a royal pain. And then you have to deal with versioning and that, getting that into the build and everything else. So that's really not, that's depending upon where you work, that's a non-starter. So installation of Gradle is fairly simple. It's similar to Ant and Maven. You download from Gradle.org. You set up your two environment variables, Gradle home and path. Gradle, I believe, does use the Java home for finding its Java version that it's going to use. And the command line is Gradle, which is very similar to, you know, not similar, but it's a command line utility like you have with Ant or Maven. So it's pretty straightforward for moving over to Gradle. The key Gradle files are build.gradle. You've got your settings.gradle, so those two are in your project directory, kind of similar to analogs in Maven, where pom.xml, and then the properties file. You have the local settings in your off your home directory, which allows you to put database passwords for regression testing, which I'll show later in the presentation, where I'm running a regression test and I need to connect to a local database. And then your local repositories in /Gradle. And the build.gradle is equivalent to your pom.xml and build.xml if you're coming from either of those two worlds. And you can rename the file anything you want. Gradle, on the background, one of the performance benefits of Gradle is something called the Gradle daemon, which is enabled by default. So when you start up Gradle, basically it stays running in the background so that the next time you kick off a build, it's already warm and running. Now with that, the one caveat to that is that up on your integration server like Jenkins, you want to make sure to disable the Gradle daemon, because you want to do a clean build every time. You don't want the thing running with an already running instance of it. You can display the status of the Gradle daemon by doing Gradle-status. See how many daemons are running, because if you're like me, you'll kick off a couple of different builds in a couple of different windows as you hop between things. Sometimes it's just handy to find out what's running. You can stop the Gradle with Gradle-stop. And then finally, for the disabling the daemon, there's a property that you can set in the local configuration file to control that. So project creation is straightforward, although not as straightforward as it is like with Maven. So with Maven, you've got archetypes, so you've got like a predefined project structure which you can bang out. With Gradle 3, we've got this init, so it'll create the initial project for you. If there's a POM file already there, to read the POM file in and try creating a project for creating Gradle files for you to mirror that project. It does work with multi-module projects. It'll do its best to parse the POM XML and build you a set of Gradle files that will do the build. So if you're moving from an existing, if your project is currently on Maven, you want to try moving over to Gradle, that's the easiest way, because other than that, you'd have to hand edit files in order to do that. With the init, you can specify a Java library, a Scala library, a Groovy library. If you don't provide anything basic, which just puts out the source directories, no source directories are created, but it puts out the Gradle build file and the properties file to get you started along with the wrapper. And it defaults to JCenter as the content repository, which is gaining steam over the Maven one for a number of reasons. I think JCenter uses HTTPS, which Maven doesn't. And I think it's fairly easy. I was reading something that it was fairly easy to fake credentials and publish stuff to Maven, whereas with JCenter, I guess it's a little bit harder. It's a little different. You can actually check your dependencies to make sure somebody hasn't published a competing library. So after writing Gradle at init, you end up with this structure over here, which looks, which is the default structure. But you don't have to take this. You can take and customize it, and that's one of the things I'll be demonstrating, importing a old project in. And the initial build file that it generates is this. So we've got up at the top, apply the Java plugin, which means we're going to be building something with Java. And it inserts the repository JCenter and the thing for a logger and the JUnit. So this is the starting point file that it creates for us. And then to find out from the command line what we can do with this, we can run gradle-q-quiet-tasks, and that will list out all the tasks with the current build file that we can run. So it'll give us, and also print out the description along with it. And if we add any tasks to our thing, to our build file, they will show up here as well. So this is an easy way to find out, what can be run, what can you run, versus in the old days having to open up the Ant file and go hunting. And so this is just more continued Java doc in it. We've got various things in here. There's a dependency insight, which I'll show later in the presentation, which allows you to see a nice little tree graph of all of your dependencies, and who's importing what, and how did you arrive at that. Okay. And so when you do a build, of course, it outputs it to the libs directory, and the build directory, just a little bit different than Maven does it. Now in terms of project versus tasks, so this is, we've got 3 different projects where the projects have dependencies on other projects, and tasks have dependencies. So this is all built in and supported by Gradle, of course. So a project can represent a library, a web application. It doesn't necessarily represent something to be built. So you could output 2 artifacts from it, 2 different jar files, a jar file and an Uber jar file containing your code and all of its dependencies, etc. Tasks are basically equivalent to the like the Ant tasks, so they're an atomic piece of work to be performed, and tasks can have dependencies, which I've shown in this diagram here. Okay. And so understanding the build, so you look at that build file. The thing with XML is that with the schema file, what you can, what's legitimate code that you can put into the XML file. With Gradle, how do you go about figuring out what you can type in here? Well, the Gradle file itself corresponds to project, so you can kind of think of project as being the default object for the file, like in JavaScript land, where it's the frame of the web browser that you get access to when you do like console.log, right? So with Gradle, it's actually, there's a class that basically underpins that file, which is the project class. And so when we type apply plugin Java, what we're actually doing is invoking that method on the projects class. So you can go look at the Java doc for project, and you can find out what methods and tasks that you have access to there, besides their besides their documentation. So we could have done up at the top there, instead of apply, we could have done project.apply. That just project is already built in. That's the current scope that we're operating under. Okay, and then tasks are the same way. So these are the list of objects for tasks. And then so for defining tasks, there's several different ways of doing it, which I illustrate in this diagram right here. So there's more than one way to define a task, which makes it kind of fun. So I'm assuming that there'll have to be like coding standards for different organizations, because there'll be like a right way to write a task and a wrong way to write a task, right? So we've got three different examples of tasks here. As you can see right here, the first one, I set the description. I add an ad hoc property, which I can then do the string interpolation with, which that should have had double quotes around it. So the first one is just demonstrating adding a description, adding an ad hoc property on the file, and then you have the do first and do last for doing that. Now, one of the things is that you can add code to existing tasks in Gradle, which you cannot do with an Ant. If you have an Ant task, how do you add additional code to the build task in an Ant file? You really can't. With Gradle, you can do that. With the tasks down here, the next one just uses a different syntax for doing almost the same thing. And then down here, we're actually taking a task and we're building off of the existing copy task and calling methods on it to do stuff, to move files around. In terms of task dependencies, same type of thing. We can list depends upon for the in terms of we have a first task, a second task. We set the default task for this project, and then we set up the dependencies between them. Okay. Now, one of the nice things with that printout that we saw before, where all the tasks were grouped into different segments, logical segments. With Gradle, you can actually group tasks, so you can specify on a task which group that they apply to, so that when you go to list the tasks, it's just not the order that they appear in the file. So if you've ever worked with, with like Ant files, where you have to like put tasks in certain orders in the file, or use a certain naming convention, so you can easily find stuff. With Gradle, you can actually group the tasks so that they're easy to understand when looking at the build output. And then, when you're in IntelliJ, it prints out the grouping. Okay, and then as you saw from the previous code example where I had the apply the Java plugin, there's many different plugins that are available for it. So there's the Java one, which is the base one, application for basically creating distributable application. The ear and the wharf ones are the ones that we're primarily going to look at today. There's also plugins for IDEA, Eclipse, etc. So there's standard. I have a link down there for standard ones and also third-party ones for Gradle. So Gradle does support multi-module projects. There's two different ways of doing this. You can either do the hierarchical layout or the flat layout. I'm going to focus on the hierarchical layout today, where you have a build file and your properties file, and then each one of the modules that makes each one of the projects that makes up your thing, I call modules, have their own Gradle build script and properties file, whereas the flat layout is a little bit different. So as an example, Connecticut Java Users Group, our web application, we have a build.gradle. It's a hierarchical layout, so this is the structure of the projects for it, where we have a Gradle one. And the nice thing about Gradle is that I can apply up in the build.gradle. I can set configurations for these. So I can set a global that all the projects are using the Java plugin, and they all use this dependency, or this set of dependencies, or this set of settings. So it allows me to easily configure the entire project from up there, whereas I don't have to duplicate this stuff everywhere. So this is an example of that, where I've used all projects to map what goes in, and then in the Gradle settings, I specify which modules make it up. Okay, and then the hierarchical layout we have in the Gradle.settings, the root project name, and then when I go to include like another module, you specify compile, and then the project that you're pulling in. Okay. And now in terms of IDE support, with doing Java EE, if you're using IntelliJ, you need the paid version. Otherwise, the problems that I've run into is it doesn't recognize the JSF tags or the tag libraries that come with Java EE and some of the configuration files. So I've gotten the best mileage out of the paid version of IntelliJ versus the free one, where it wouldn't recognize any of the files. NetBeans, there is a Gradle plugin for NetBeans. Sadly, however, it does not appear to work correctly with multi-module projects that use Java EE, and it also doesn't recognize that the project contains Java EE artifacts, so you won't get the nice CDI features that you would if you're using a NetBeans Java EE project. So you lose a lot of the features, and then you have to figure out, you'll have to write Gradle tasks to run your to fire up the IDE and everything. Eclipse has a separate plugin that you download that's actually provided by Gradleware. I'm primarily a NetBeans or an IntelliJ user, so I've not used the Eclipse one as much. The IntelliJ one, I will say that the default, when it reads in a project that is an EE project, it has quite a bit of, I've had a lot of trouble with it. So usually what I do is I generate the IntelliJ project from the Gradle files. I don't have IntelliJ try to read it in, because it won't recognize, I can't get it to recognize like the web artifacts correctly, and also sometimes it screws up the provided class scope. So this is just how to install that one, and then the NetBeans one is a separate plugin that you have to go in and install. This one works fine for simple projects, just not for Java EE. and you don't get the nice integration that NetBeans has with Glassfish, etc. So, moving on to actually migrating projects over to Gradle. So I'm starting off with one that I created for this project, because I can't start off with something from work. So I've created a Java EE a war project in NetBeans, right, which has a file structure that would not be compliant with, would not work with either the default Gradle or Maven, right? It's got its source, it's got its directories in the wrong place. So as you can see here, this is the file system view. So the web artifacts are under web. We have a source directory, and the source directory underneath it, I think, just has the source code in it. There's no other layering with it. And so, you know, we want to move this project over to a Java EE project, and then on top of that, I have a third-party library that is not available in any centralized repository, right? That's in the libs directory, just for an extra curveball in there. So it's not there. So I'm trying to deal with a custom layout with a jar file that's not in any repository. So the Gradle file for this is a lot shorter than the Ant file, for sure. So up at the top, I have my plugins. I have the IDEA plugin just because I want to use IntelliJ with it. JCenter, and then for flat directories, I specify that the lib directory contains the jar files that I'm going to be after. The source sets, I define the location of the Java files and also the resources, which happen to be in the same directory. And then under dependencies, I specify the local library, that library that I have in there minus the jar on the end. It adds it for me. And then for provided compile, this is actually new in Gradle 3. They've got this provided compile now. That is how you pull in the Java EE, you know, the container dependencies, so that they do not, so it ends up on the compile class path, and also is used for testing, but doesn't get built into the war file, right? You don't want to deploy your Java EE implementation to your war file, because all kinds of very interesting things can happen at runtime. And so for including, when you do things like put the WebLogic class path into the war file, then deploy that on Glassfish, that gets really fun. So then down here, I specify for the war plugin, this is configuration for the war plugin, and I specify the location of the web resources directory. And then the war plugin has a bunch of configuration settings where I can specify where the web.xml is, the web directory, class path to go into lib, and that's pretty much it. That was pretty straightforward to get a existing war project over into Gradle. Of course, most projects are going to be much more complicated. You're going to have multiple modules with it, so that's a very simplified example. The next one is, as a part of this project, you have to have do minification. Now, there's two ways of doing the minification. There's one way is using the Google plugin, the Closure Compile, with Google to minify your JavaScript to output one consolidated JavaScript file. The other way is if you have a complex project where you're using Grunt and you've got some JavaScript people and people writing Sass, where you want to use the Grunt tool chain for doing that compiling. That's a separate way that you can call off from Gradle, which is much more involved, where you actually execute the Grunt jobs in order to do that. But in this case right here, I'm going to stick with Java and pull in the Closure Compile. I'm adding an extra variable to an ad hoc variable for the output directory for the JavaScript. Okay. And then I add my task, which is going to basically, because that other thing is basically an Ant task, I'm actually going to invoke the main method on it. So I'm going to extend the Java exec built-in task and invoke the minifier passing in my files, JavaScript files. And then at the end, I'm going to war them up, and I have a flag in there, an optimized flag, because usually during development I don't want to have the JavaScript minified. I want to be able to debug it in the web browser. So that's just allowing me to control that, and then when I do the build down below, I can pass it in, or I can set that in my properties file, so the final build server, builds with that as being true, and my local build builds with it being as false, so that I don't build with it. So that's basically doing JavaScript minification, and the same approach. You can use the JS lint stuff. You can do all of those types of tasks in order to clean up and to do the building. Now, the next more complex problem is dealing with the JPA Meta-Model, right? If you've tried to use the criteria builder, so with JPA, you can build out the meta-model where it takes and builds up classes so that you can programmatically create queries. So you could dynamically create queries at runtime that are type safe. So it was the new meta-model that was introduced, I think, in Java EE 6. So it does that via an annotation processor at build time. So it goes over and it actually generates code for you that you then have to get into your class path so you can compile the rest of your project, right? So it's kind of a chicken and the egg thing. So you'll have your data model, and before you can compile the rest of your code that uses built-in, these generated classes, you have to generate that part. Now the really fun piece of this is the Eclipse link doesn't like other CDI, like some of the other CDI annotations, because their annotation processor, I think, was written for Java 6. So which means that you have to hide the other things. So in order to get this to run, because there's no built-in support with Gradle, you end up writing a custom plugin for Gradle in order to do this. So this is written in Groovy. So I have down off of the custom plugins that get checked in with your code that you write, go under build source, and I've put it's a Java APT plugin for the processor, and then a properties file which contains which class in there implements the plugin thing, which I'm going to reference from my main build file. So that's getting the plugin set up. Now this kind of demonstrates another powerful feature, is that you can write ad hoc classes and include them as a part of your Groovy script. So you're not just limited to what Groovy comes with it. You can actually write your own classes that do things, put them in the source directory, and then use them from Gradle, which is kind of powerful. If you've ever had to do, I'd like to say on the previous slide, if you've ever tried to do that if type logic in Ant, right, unless or something like that, you end up with really wretched code to try to get that done. And then this is the actual APT class, which is actually invoking the annotation processor to do that. So I'm going through and building up the compiler and invoking it, setting the class, setting this generator. Basically, I'm setting it out to a generated source directory, which I'm then going to group up with the rest of the build. This is the rest of it. So as you can see, I'm pulling in, generating. So what it actually does is it generates, the annotation processor generates Java source code files, which you then want to compile with your project, but which you don't want to check into version control. So you want to keep it in a separate location.
So why is the source name not being built?
That's Java Gen. Yeah, I should have put it in built. But yeah, so I was lazy and stuck it there. That's actually a cut and paste error. So then in the main build file, I've got the compile for Gradle API, so I'm going to build the plugin and also use the local Groovy. And then down below, I only want to include classes from my data model, which happen to be in the DAO package. So that's where the classes that I want to have it run the annotation processor over, because if it hits any of the other classes, it's going to, the older Eclipse link thing is going to complain about it. It's going to give a really weird error. I think it's with the resource annotation. And so for that, it needs the persistence.xml and a bunch of other things. And you can see building up the class path for it, because I want to use a class path for the annotation processor, but I don't want the Eclipse link jars included in the final build output, because I don't want those ending up in my war file, because the container is providing those. Right. So that was the annotation processor. So that's a common Java EE problem. The next one is ear project. So if you're not using the simplified approach with war files, where you can put your EJBs in war files, if you're building complex projects where you have ear files and multiple modules, Gradle does have an ear plugin which will generate a WAR file as output. So on the left I have, it's a hierarchical project structure, so I've got my ear project, my EJB project, my model project, and then also the web app project, which is similar to the ones that we saw before. And then over on the right you can see what the output is. This is actually, I took the ear file and exploded it to find out, you know, to look inside of it. And of course it generates the application XML for me. So the plugin, apply the ear plugin. I specify under the dependencies the deploy, so deploy project web app. So I'm saying I'm going to pull in the web app project, I'm going to pull in the EJB project. The model project is going to the ear lib directory. And then down below I set up the configuration for the ear itself. So I specify, you know, the initialize order, the display name for it. Substitution with the build. So I have, I'm actually going to leverage a Maven plugin in Gradle for doing this. So as a part of my build, I want on my data model, which requires talking to a database. So I want to have, as a part of the data model project, I want to have it actually populate, actually create a test database and then run unit tests against it, which means I need a persistence.xml, and every machine needs a different set of credentials potentially for the database, right, depending upon where you're building it or who is building it. So I want to parameterize those out. So here I parameterized out, I could have done it for the driver as well, but I parameterized out the URL, the user, and the password. And in my home directory there is that the .gradle, the gradle.properties file. I put in, you know, env db URL equals such and such, the username and the password, and then at build time I want to blit those in and then run the unit tests. And also the unit tests, because the unit tests are using CDI, I have to get the CDI beans, the bean.xml over into the test class path, because at last check it was not compiling. I could not, it was not including it by default, even though it was there. So I had to copy over the beans.xml so my CDI testing would work. Now I'm running in this module is running a Java SC, but I actually fire up the CDI container so I can test injection. So I need to include my beans.xml file, copy those over. So this is where I'm taking the test task, and before I actually run the tests, I've added a block of logic to copy over the beans.xml. And I don't know why I did that twice. I copied it twice. Okay. Yeah, you know, if you do it twice, you know it worked, right? Oh, okay. Yeah, I didn't know. Okay. Yes. So it copies over now. If you know, for like the Ant build file for NetBeans that it generates, you'll see where it has all of this before test, and it's got this whole convention, naming convention, so you can do things like this with an Ant build, right? So this is one of the nice things with Gradle, that I can tack onto an existing task that says, okay, you know, I have the task, you know, task, and I want to extend it. I want to do something before I run it, but I don't want to have to, add, edit the build file, right? And then down below, I'm using the Ant. Actually, I said Maven before. I'm using the Ant. I'm doing the filtering down below. So I'm using the replace tokens to replace the DB, env, URL, etc., wherever it appears in the build input. Okay. And then testing with Hierarchical. This is very straightforward. As you can see right here, I've included the dependencies for Hierarchical, so I can do testing. That allows me to do container testing. So all the same stuff that you do from Maven. So if you go up there to the Hierarchical website, you'll see where they have the example code. All the stuff up there works with Gradle as well. So I'll actually show you some of the tests in a second with that. And so let me hop over to back to the IDE. Now you'll notice that when I'm looking at the Gradle files here, I've made them plain text because I've generated the with IntelliJ. The problem that I have with the Java EE projects in IntelliJ, if I use their built-in Gradle support, it won't recognize the web modules correctly. It refuses to recognize the web module roots and won't see that. So that's why I use Gradle.idea, and then I turned off the Gradle support because it thinks that the files have errors. So this is a simple test using Hierarchical, which is testing a web service. So I'm actually firing up Glassfish or Pyra as a part of the build and building it. And this test actually this test fires up Glassfish using Hierarchical as a part of the build process, and also starts a web browser to test the JavaScript in the web browser, making a RESTful call to the server. So I'm doing full testing. I'm testing the back end, and I'm testing the front end in the web browser. So I'm using Selenium for that. So it's using, in the case right here, it's using phantom.js. So there it sets it up, and for the now this is nothing to do with, this is independent of Gradle, but this is just showing you that you can use all of the same tools all of the documentation for Hierarchicals in Maven, but it still works with Gradle. So I've, in that last snippet there where I included all the dependencies for Hierarchical, I was able to run my unit tests and do some very sophisticated testing using that. This is testing RESTful web services. So I build up the classes that are build up the packages with the classes that are necessary for it. They're run with Hierarchical and tells it that I'm going to use the container. It pulls in the configuration files that I have over here under test and runs the test with the container. So just out of curiosity, how many of you are using Hierarchical? Okay. So this is one of the, so this is easy to actually integrate. This allows you to actually test your EJBs and your RESTful endpoints, everything from within the file. It starts up the container, shuts down the container for you. And you can specify modded properties. You can actually, by substituting in that line before where I copied over the beans.xml, what you normally do is, but depending upon the test that you're running, you copy over a different beans.xml, and using CDI you can stub out like the DAO layer. You can specify a DAO layer that likes to throw exceptions and test how do the exceptions, if you throw a SQL exception, how does that propagate up through the RESTful endpoint? What HTTP code gets returned to the user, right? You can simulate all of those test cases, and it's fairly easy to do. So that is using this, and then where is now one of the things that I've had trouble with is trying to figure out when something goes wrong with the Gradle build, what was it actually running for the class, what was it actually running for the Hierarchical stuff when something goes wrong with the build. So I use the exploded exporter, which comes with shrink wrap, to actually blit everything out so I can see what Glassfish was started up with and what did it run with, what was it seeing. Okay. And some more tests right here. This is actually using the phantom.js driver. You can also use Firefox and Chrome to do the testing. Okay, and then a couple more. So one is Gradle. So we can view the list of dependencies using specify the module name and then dependencies. So if I hop back over for this project, which has a huge number of dependencies. We're going to see it fire up. And we can see all the dependencies for the project, and all the transitive dependencies and everything that's included. And there's plugins out there that will allow you to try to find duplicate dependencies. So within the graph, do you have two things including the same thing, so you don't have to go through it yourself and do it. And then there's also, going back here, we can see what else do we have. We have the Gradle GUI. Which gives us a nice UI for interacting with Gradle from a GUI when we don't want to use the command line. And we have troubleshooting things. And let's see. Port still open? No, I don't. We can also run it with dash profile, and that will give us, the time that it's spent in every task, so we can kind of troubleshoot, look at, performance problems with the build and try to troubleshoot what's going on with the build. Why does the build take, 3 minutes, or why did it take 10 minutes to run a build? What was it doing? And also dry run, which allows us to see what would be executed. And the one thing I didn't touch on much was the incremental build, that with Maven, every time you do a build, it does a clean first, and then it recompiles everything. With Gradle, it keeps track of, what did you build before. So, if you didn't make any changes, which is the same thing that your IDEs are doing, right? Eclipse and IntelliJ both do incremental compilation for you, and that's why when you click that, you make a minor little change in code, and you click run. That's why it builds and runs so fast. Yes? Into the what?
That would make it actually rebuild the Java files every time.
To put the date in the...
Yeah, rebuild.
Oh, okay.
That was bad because then Gradle saw, oh, it has changed. It has another timestamp.
Oh, okay. Yes. So yeah, not do that. But yeah, so it gives you the incremental compilation, and when you write custom tasks, you can even take that into account. So your custom task and custom logic can take into effect that you have that you are handling that you can handle incremental builds. So with that, thank you. And if there's any questions.
Do you know if they have a JavaScript plugin yet? So we don't have to use XJC from Ant anymore?
Not that I'm aware of, although there are a bunch of new things that came in with Gradle 3. So I haven't, I've only recently upgraded to Gradle 3. So I'm still in the process of switching my projects over, because I was previously doing the old way of handling dependence.
Yeah, but it has issues.
Yeah, it has issues, yeah, but
It's actually XJC, isn't it?
Yeah.
I tried to avoid XJC, but
Yeah.
Why it's module in the tool?
Yeah, actually we use it just running it with I think with Java exec, not using the Ant task, but just Java exec. That works fine. The plugin, some of the plugins, the JavaScript plugins, it had some issues with schemas, importing other schemas and stuff like that. Problem stuff.
Yep. So and I'm still porting my build files over from having, because was doing it the old way before they had the provided classes, which came out in 3, right? So I was creating the custom configuration for the provided, which was not there previously. So if you go out and Google that, most of the hits, unless you type in explicitly Gradle 3, you'll get everybody's blog entry for doing it the old way. Yes.
We have a lot. We're doing camel integrations. We have lots, like 100 projects, and we want to separate our certain aspects of our build logic out into common stores, so we can basically improve it and make it better. The only way I found to do that was to write custom plugins. I mean, well, what I'm doing right now is I'm basically I'm including scripts from an HTTP server, but that means that you can't build anything if you're not online, and that's a bit annoying.
Okay.
Have you ever heard of any ways around this? Because like writing my own custom plugin just to get our PMD rules set up, or our findblock rules or whatever, to be.
Yeah, no, I've not actually tried doing that with it. I've run, you know, the default like code checkers for SAS, but I've not tried to pull rules from some other place. Like
No, it's just
like
that
use.
we want to pull the build script, like include build script or whatever.
Okay.
Uh,
Yeah, no,
it's not very-
I've not tried doing anything like that. For some of the projects I've been advocating for actually splitting them up into modules and publishing them to a repository so I can then pull dependencies down that way. Because I don't quite, I don't,
Okay.
Yeah.
I'll take it up.
yeah.
Yeah, I was just, is there actually IDE that works with Gradle? You told me about it's not working on I disabled stuff and.
Yeah, so that's been, I think Eclipse is probably the best one with their plugin, but I have not tried the Gradle 3 stuff after I switched over to the Gradle 3.
Anyone has any experience with Eclipse and Gradle?
Oh, not free, but we do use Eclipse with free. Yes, but
With no
that's
problem.
That's 2. So the problem,
Point to
Anyway.
yeah, I was on 2.8. I've run into trouble with the provided class path where it's not recognizing the fact that they now have that provided classes, so it wasn't getting mapped in correctly. So I've had minor problems with that.
We're using IntelliJ with Gradle 3 and it's working well, but then we're not doing JSF and very fancy web stuff.
Yeah, so that's where I run into trouble, is that it breaks down when I'm trying to do JSF, and then trying to deploy it. So-
Avoid web applications at all costs.
Yeah, so that's yeah, so it's frustrating because IntelliJ has a good editor for doing that, but then the NetBeans, the Gradle plugin over there doesn't work with multiple modules, so I don't get my usual integration for firing up the containers and quickly, you know, doing debug sessions with it. So it's very frustrating. What's that?
Isn't there like a Jira ticket for that? When people looking into.
Yeah, there is somebody was building a plugin on their own, but I don't know if it's moved along that far. I couldn't get it. There was one other plugin one other plugin in addition to the Gradle one that added IDE support to NetBeans, except I couldn't get it to work right. Couldn't get it to recognize. That's it.
We need to wrap like close.
Okay.
Thumbs up. Next figure is ready.
Thank you.
So